Hello and welcome back to Student Data. In this video, I'm going to talk about negative binomial distribution and its properties like mean and variance. Okay, let's get to it without further talking. The negative binomial distribution discusses the final success that can be attained following a string of successes in earlier trials. The rth success in a negative binomial distribution is one that has been preceded by n-1 trials, each of which contained r-1 successes. Actually, in a simple word, negative binomial distribution is a generalization of a geometric distribution in which the random variable is the number of Bernoulli trials required to obtain R successes. But before diving into negative binomial distribution formulas, let's see a simple example. Suppose that the probability that a bit transmitted through a digital transmission channel is received in error is 0.1. Assume that the transmissions are independent and let the random variable x denote the number of bits transmitted until the fourth error. Then x has a negative binomial distribution with r equals 4. Probabilities involving x can be found as follows. For example, the probability of x equals 10 is the probability that exactly 3 errors occur in the first 9 trials and then trial 10 results in the fourth error. The probability that exactly 3 errors occur in the first 9 trials is determined from the binomial distribution to be 9 choose 3 times 0.1 to the power of 3 times 0.9 to the power of 6. Because the trials are independent, the probability that exactly 3 errors occur in the first 9 trials and trial 10 results in the fourth error is 9 choose 3 times 0.1 to the power of 4 times 0.9 to the power of 6. Now let's see the negative binomial distribution formulas. In a series of Bernoulli trials, the random variable x that equals the number of trials until r successes occur is a negative binomial random variable with parameters p that is between 0 and 1 and r, and its probability mass function equals x minus 1 choose r minus 1 times 1 minus p to the power of x minus r times p to the power of r. On the other hand, if x is a negative binomial random variable with parameters p and r, then its mean equals r over p and its variance is equal to r times 1 minus p over p squared. Now, before wrapping up the video, let's see a simple example again. The time to recharge the flash is tested in 3 cell phone cameras. The probability that a camera meets the recharge specification is 0.8 and the cameras perform independently. We are interested in the probability that the third failure is obtained in 5 or fewer tests. Let x denote the number of cameras tested until 3 failures have been obtained. The requested probability is equal to the probability of x is less than or equal to 5. Here, x has a negative binomial distribution with p equals 0.2 and r equals 3. Therefore, the requested probability is equal to 0.2 to the power of 3 plus 3 choose 2 times 0.2 to the power of 3 times 0.8 plus 4 choose 2 times 0.2 to the power of 3 times 0.8 squared. and that is equal to 0.058. And these two numbers are the mean and the variance of our question. Now let's wrap up the video by reviewing what we have learned so far. First, we saw that the negative binomial distribution is the distribution of the number of trials needed to get, for example, our successes. Then we saw its probability mass function, which was equal to x minus 1 choose r minus 1 times 1 minus p to the power of x minus r times p to the power of r. And finally, we saw its mean and variance, which were equal to r over p and r times 1 minus p over p squared. And that is done. Congratulations! Now you know what the negative binomial distribution is, and you can solve and model real-world problems with its help. And remember, for more information about other distributions, you can check out this playlist. Finally, if you like this video, please hit that like button, and if you are interested in statistics, data science, and machine learning, please consider subscribing to this channel. By the way, if you have a question about the fields I mentioned, comment it down in the comment section. And don't forget to share my videos with your interested friends. I hope this video helped you a lot, and until the next video, happy learning!